In this video, we are going to go over how to divide powers. Let's see what the rule is all about and why it works. So we're going to check out two problems right here where we're dividing powers. And really our goal is to simplify these expressions, but I'm going to do this first by expanding the numerator and denominator. So here we're given 2 to the 4th over 2 to the 3rd. Well, 2 to the 4th is 2 times 2 times 2 times 2. So I'm going to expand that out like this. So we get 2 times 2 times 2 times 2. And that's all over 2 to the 3rd, or 2 times 2 times 2. 2 times 2 times 2. And what we'll do here is we'll use our common knowledge of how to divide. Since these are all products and these are all products, we can divide common factors. So 2 divided by 2, that becomes 1. Another 2 divided by 2, that becomes 1. And another 2 divided by 2, that becomes 1. So we're literally going through and pairing up all the 2's, and each of them become 1's. And so what we're essentially doing is, well, subtracting by figuring out the number of pairs of 2's that we have, right? So every match of 2, we're subtracting out a pair of 2's. Now, are we actually doing subtraction? No, we're doing division. Each of these equals 1. So it's kind of like you're left with 1 times 1 times 1 in the denominator, and 1 times 1 times 1 times 2 in the numerator. So all of that leads to being 2 over 1, or 2. But at the end of the day, what we're really doing, again, is subtracting. Isn't that awesome? I think it's pretty cool. All right, let's check out this next piece. Here we've got a to the 5th over a to the 3rd. So we're going to expand out a to the 5th and a to the 3rd. So we've got 5 a's up top. 1, 2, 3, 4, and 5. And we have 3 in the bottom, the denominator, as we're told by a to the 3rd power, 3 times that we're multiplying a. So again, as long as a is not 0, because we can't divide by 0, we will be dividing out. A divided by a is 1. A divided by a is 1. A divided by a is 1. Essentially pairing up and taking them out of the problem with division, but really we're subtracting the number of times that a is being multiplied in the numerator and denominator. And so we're left with 2 a's in the numerator, that's a squared, over 1, because each of these, again, this is 1 times 1 times 1. So these are all become 1's. So we're left with a squared over 1, or a squared. Again, what we've done is we've subtracted the number of a's that have been multiplied up here by the number of a's, the same base that have been multiplied in the denominator. We've got a bit of a shortcut here. I think we could take in either one of these. In this problem, I could have just kept a and subtracted 5 minus 3, the number of a's in the numerator minus the number of a's in the denominator. The same here, the number of 2's in the numerator minus the number of 2's in the denominator. That's it. So that leads us to our general rule. When we have the same base in powers that are being divided, we keep the base the same, and we subtract the numerator's number of those bases being multiplied minus the denominator's number of bases being multiplied. In very simple terms, we keep the base the same and we subtract the numerator exponent by the denominator exponent. That's it. Awesome. So let's exercise this. Instead of expanding this out 15 times and then 7 times and then canceling out with division all the matching pairs of x's, how about we just recognize we have 15 x's over 7 x's. That's going to leave us with x to the 15 minus 7, which simplifies to x to the 8th power. Awesome, awesome stuff. In a later video, I'm going to go over several examples of how to use this property, but now that you understand why, I hope that you've got this rule, very efficient and very useful rule, locked up there in your brain.